What is up, YouTube? Welcome to Teaching Trends. My name is Carla. I'm teaching you all about those healthcare topics and things that you're learning in school right now, as well as topics on jobs, healthcare, remote jobs, and some other topics. Welcome back to all of my returning viewers. And for those of you who are new, welcome to my channel. Today, we're going to be talking about how to read EKGs. So if you haven't seen my last two videos, make sure you take a look because it will be important for you to understand blood flow and the different parts of the PQRST complex. That being said, we're going to move right on to learning rhythms. Just as a quick refresher, one complete cardiac cycle or one heartbeat is represented by the PQRST complex. The P wave that you see on the right-hand side also includes what you see a PR interval. That will come into play when we're interpreting. The PR segment, which is also important, the QRS complex, and the ST segment. There's also a QT interval. So make sure you know where these sections are measured from. An interval has a waveform in it. So that's how I remember interval versus segment. A segment is more so of a straight line and does not have a waveform in it. If you take a look at the waveform on the right-hand side of the screen here, you will see that the PR interval has the P wave in it. The PR segment does not. The QRS complex is an entire complex, the PQRS and T. The ST segment that we see here does not have a waveform in it, but the QT interval at the bottom does have the Q, R, S, and T within that interval. Make sure you know where to measure from and where it begins and ends because it is a vital step in measuring EKG. Remember that the P wave represents atrial depolarization or atrial contraction. So if the P wave is not normal and upright and rounded, and it looks a little funky or it looks a little different, we can assume this may be some sort of an atrial rhythm. The QRS complex. The QRS complex represents ventricular depolarization or ventricular contraction. The atrial resting or repolarization is also buried in that QRS complex. The QRS complex represents ventricular rhythms. So if we have an abnormal looking QRS that is wider or bigger than normal, then we're going to determine that that's some sort of a ventricular rhythm. And the T wave represents ventricular repolarization. I made an entire video about this QRS complex and how it is formed, so make sure you check that video about the electrical conduction system out. In order to understand how to read EKG, you have to understand the purpose of the graph paper and the paper that it's printed on. The paper actually represents time and what we consider voltage or amplitude. So when we're looking at this, we're looking at horizontal across the actual EKG. When we're looking horizontally, it represents time. So as the EKG prints out, it is detecting the time it takes for the waveforms to print on the paper, how long some of those waveforms are or how short they are. And that can be measured by looking at the boxes. One large box, as we can see on this screen, is 0.20 seconds. So if you take a look at that down at the bottom, and one small box is 0.04 seconds. Time goes across horizontally on an EKG, and voltage is measured vertically. Voltage, as you see here, measures the height or the amplitude. The voltage is measured in 0.1, 0.2, 0.3, 0.4, 0.5. And as you can see, we have 10 boxes tall on this EKG, which means our voltage would be 1.0. Each box is 0.1. 10 of those boxes that are 0.1 equals 1.0 millivolts. So time going across on the EKG and amplitude going vertically. The width of every square is considered 1 millimeter. That 1 millimeter box is 0.04 seconds. That 1.04 seconds is one small square. 5 small squares equal the large square at 0.20 seconds. The darker lines divide the paper every 5th square, as you can see to the right. And as I mentioned, one large square, 0.20 seconds. So we've got the 5-step approach in order to interpret EKGs. We should be looking at the heart rate. What is the rhythm? Is there a P wave? What's the PR interval? And what is the QRS complex doing? These steps should be followed when you're doing EKG interpretation. We're going to talk about how we determine the heart rate, the rhythm, the P wave, the PR interval, and the QRS complex. There's multiple methods to determine the heart rate. In a 6-second strip that is typically marked by a tick mark at the bottom of or top of the paper, you're going to count the number of QRS complexes occurring within a 6-second strip, and then you're going to multiply by 10. This method can be used accurately for heart rate. As we see here, this is the 6-second method. If you were to count the complexes, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 10 is 80. This method typically only works for a rhythm, however, that is consistent R to R. And what do I mean by that? Where the little arrows are determines the R to R. Remember, the top of the complex is the R, the QRST complex. So this rhythm, as you can see, the R's reasonably fall in an even pattern. This means that the rhythm of the actual heart is consistent. Please scroll down to the heart rate chart. How we can determine some other rhythms is count the spaces between R to R, find the number of spaces on the chart, and then determine the heart rate. So the spaces that we're counting are small boxes. So to the left, as we can see here, 3 small little tiny boxes between complexes would be about 500 beats per minute. 6 little boxes between complexes would be 250 beats per minute. Look at 25 little boxes would be 60 beats per minute. So the boxes we're talking about for this one are not the large ones, but the tiny ones that are in between. How can we determine these tiny boxes? Well, we can count by 5 because we already know that 5 of these little boxes live within the large. So we can count 5, 10, 15, 20, and then whatever is left, add it up for our heart rate box. So that's a way to determine the heart rate. If you have a really handy chart of heart rates, over time, you'll start to recognize how some of these numbers start to stick in your head with how many boxes there are. But it's a great way to determine what your heart rate is. If we can determine the heart rate, then we're on our way to determining what the person's heart rhythm is based on their EKG. Here's an example of how to count the heart rate. Find the R to R. It's showing the R to R here. And in that space, there's 15 little boxes in the R to R. We'll find 15 spaces on our chart and it should say 100 beats per minute. So we go to there, and sure enough, it does. So, fairly simple on how to calculate the heart rate for our EKG. Next, we're going to determine if our rhythm is regular or irregular. Regular means the intervals from R to R are regular, they're evenly spaced. Irregular means the R to R is not regular. So, we're going to take a look at some of those rhythms and determining. Before we do that, let's do a quick review of our voltage in millivolts, 0.1 millivolts for a small box vertically, time, 1 point, I'm sorry, zero point zero 0.04 seconds in a small box, and a large box is 0.20 seconds. We have our P wave that is responsible for the atrial contraction, the QRS that's responsible for the ventricular contraction, and the T wave that is resting. You want to measure between the R to R interval to find the heart rate. So we're going to check this out. Here we have a normal rhythm. The R to R is consistent. It's about the same amount of boxes in between each QRS complex, PQRST complex, and showing in a regular rhythm. Initially, it looks like the R to Rs are pretty consistent. But as we go towards the end, we take a look and we see that this is an irregular rhythm. So those are things we have to determine if they're a regular rhythm or not after we determine what our heart rate is. The next thing we're going to do in our interpretation is see if we have a P wave. A P wave is produced by the SA node and is the first positive upright deflection on our complex. If your rhythm has a P wave, then that makes the rhythm sinus. So if your doctor is asking, or your nurse, or you're working at a facility and they're speaking about sinus rhythm, that means your rhythms have a P wave. The P wave needs to be there for all QRS complexes, or it's not considered a sinus rhythm. It may not be. So we have our P followed by a QRS complex, another P followed by a QRS complex, so on and so forth. This makes a rhythm sinus. So in this video, we're going to talk about the sinus rhythms only, and I'm going to make a separate video for ventricular rhythms and for heart blocks. So if you're more advanced and you want to move on to those other rhythms, I will make a video on those in the coming weeks. So what are we looking for when it comes to our P waves? Our P waves, are they present? Are they regularly occurring? Is there a P wave present for every QRS complex? Are the P waves smooth, rounded, and upright in appearance? And do they all look similar? These are some questions you want to ask yourself when you're doing rhythm interpretation. So we're going to go to the P wave. And again, as I discussed, I'll do the PR interval at a later time. And we're going to get into our sinus rhythms. So our sinus rhythms that we have are normal sinus rhythm, sinus brady, sinus tachycardia, sinus arrhythmia, and sinus pause and sinus arrest. Normal sinus rhythm is a rhythm that has a normal P wave for all complexes, and the heart rate is consistent between 60 and 100 beats per minute. Sinus bradycardia is any rhythm that has a P wave that has a consistent rate that is below 60 beats per minute. Sinus tachycardia is going to be a rhythm with a P wave that is rounded, where the rate is faster than 100 beats per minute and it is consistent. Sinus arrhythmia has a P wave. However, the rhythm alters or changes between 60 and 100 beats per minute. So we'll be looking at an example of all of these rhythms. A normal sinus rhythm is a regular rhythm that is set by the natural pacemaker, the SA node. So all of our sinus rhythms are rhythms that generate the P wave, showing us that our SA node is working. This would be an example of normal sinus rhythm. How do we know? We have about 20, let's say 5, 10, 15, 16, 17, 18, 19, about 19 boxes or so in there. And if we're remembering what our 19 boxes look like, I'll flip right to the chart so we can take a look at what our heart rate is for this one. So based on our 19 boxes in between, we have 79 beats per minute. 79 is well within the 60 to 100 beats per minute for our rhythm. So when we're looking at this strip, the heart rate R to R is 19. That's 79 beats per minute. It is regular because the R to R's are equal. There's a P wave for every QRS complex. You haven't gotten to the PR interval, but I'll talk about that later. And the QRS complexes are normal and regular. So this would be normal sinus rhythm. So we're going to go to our next rhythm that we have here. Sinus brady. Sinus brady is a regular but unusually slow heartbeat, less than 60 beats per minute. Here we have a P wave that is followed by a QRS complex, but the rate is much slower. The rhythm is consistent because the R to R's are evenly spaced. So this is how we would go on to interpret. What is the rate? 60 beats per minute. What is the rhythm? We know the rhythm is regular. Are there P waves? Yes. Do all the complexes look the same? Yes. So now we're going to look at sinus tachycardia. P wave for all QRS complexes. And it does look a little bit faster than the other rhythm. How do we know it looks faster? When a heart rate is faster, the complexes happen closer together or more often. When a heart rate is slower, we can kind of tell by looking at it because those complexes are further apart. So keep that in mind when you're looking for heart rate, if you just a basic difference in noting those things. So we're looking at our sinus tachycardia. This rate is really fast. It has a P wave, so it is a sinus rhythm. Our rhythm is regular because as we look at our regular rhythm, from R to R, it is evenly spaced. The heart rate is quite fast, over 100 beats per minute, so that makes this one sinus tachycardia. This next rhythm is sinus arrhythmia. All of our rhythms that are sinus are P waves that are followed by a QRS complex. Sinus arrhythmia is a normal variation of the beating of your heart. Sometimes your heart speeds up, sometimes it slows down, sometimes it changes as you breathe, the inspiration and expiration process. So if we're looking at this rhythm, it kind of looks like it's consistent from R to R. But if we start looking at it, there's about 15 boxes in one, maybe 20 in the other. And if you look towards the end of this rhythm here, you can tell that the spaces are closer together. So ultimately, arrhythmia is the changing of this particular heart rate, but it does have a P wave. So that makes this sinus arrhythmia. Last but not least, we're going to talk about our sinus arrest or pause. A sinus pause or arrest is defined as a transient absence of sinus P waves that last from 2 seconds to several minutes. We've seen sinus arrest where the rhythm looks normal. It starts with a P wave, PQRST, another PQRST, and then it appears to have a flat, long line in the center. There's no electrical activity going on at this time. There is nothing beating, so it is considered a sinus arrest or pause. Depending on how long it is, will determine if it's a pause or if it's an arrest. Doctors kind of interchangeably use this word depending on that timing. So, a sinus arrest is a rhythm where the heart rate seems normal and out of nowhere, you've got a flat line, and then your sinus rhythm picks back up again with a P, Q, R, S, and T. So, now that we know what our sinus rhythms are, let's see if we can determine what some of them are. So, we have a rhythm here. Typical that you would see the rhythm moving when you're in telemetry monitoring because you are watching the monitors in real time. So your strips will be printed out. This particular rhythm that you see has a PQRST, and the rhythm looks regular. From R to R to R, it does look consistent. And the great thing about working in the cardiovascular telemetry department is the heart rate will typically be on the screen. It is always good to know how to measure the heart rate because at times it won't capture it and you'll have to use your heart chart or count your complexes and multiply by 10 and a 6-second strip. This first rhythm is 72 beats per minute. It is a regular rhythm. It has a regular rhythm from R to R, and the heart rate is between 60 to 100 beats per minute. Is this sinus normal sinus rhythm, sinus Brady, sinus tachy, sinus arrhythmia, or sinus arrest? This rhythm is regular sinus or normal sinus rhythm. Let's do another one. So we're taking a look at this rhythm, and at the time that it is paused, we're going to be looking at, does it have a P wave? So as I'm looking, rhythm does have P waves. It looks to have P waves for all of the complexes. However, the rate is not looking all of that consistent. So if we're looking at this rate, it does look from R to R that the rhythm changes. As the regularity of the rhythm changes, but we do have a P wave. What is the changing rhythm again? That's between 60 and 100 beats per minute and has a P wave. Is it sinus Brady, sinus tachy, sinus arrhythmia, or sinus arrest? If you said sinus arrest, I see here. Nope. This would be sinus arrhythmia. Sinus arrhythmia changes. It may have seemed like there was some pauses in there, but we didn't have any pauses or any long lines there. We simply just had a changing regularity of our rhythm. Our rhythm was irregular with P waves, which makes it sinus. So this is sinus arrhythmia. Let's do another. So we have a rhythm here where it looks like the R to R is regular. we have a heart rate of 54 beats per minute, which is kind of slow. So what does that make this rhythm? Sinus Brady, sinus tachy, normal sinus rhythm, or sinus arrest? If you said sinus Brady, you are correct. Very good. Let's do one more rhythm. This rhythm has P waves, but it does look like the rhythm is inconsistent. Looking at this EKG, we've talked about the large boxes representing time. We know these large boxes represent 0.20 seconds. In the center of my screen, I'm looking at about 1, 2, 3, 4, 5, 6, 7 of those boxes. So that's going to be over the time we need for counting this as just a regular arrhythmia. We're going to count that time in between those complexes as a arrest or a pause. So what does that make this rhythm? Sinus arrhythmia, sinus tachy, sinus Brady, normal sinus rhythm. If you said this was sinus arrest, you are correct. It has a P wave followed by QRS and T. All of them have P waves. The rate is consistent, except for when we have these long pauses in between. The next video I'm going to come out with, I'm going to get into some of those rhythms. So if you're interested in learning about these different rhythms, join me on my next video where I dive into the ventricular rhythms, heart blocks, and junctional rhythm. I've had many people ask me how many rhythms there are. We have our sinus rhythm category here, if you're looking. So there's sinus rhythm, sinus tachy, sinus arrhythmia, sinus exit block, and sinus arrest. We have our next videos sorry, the next rhythms where we have early beats and atrial rhythms. So we have normal sinus rhythm with a PAC, supraventricular tachycardia, atrial fib, atrial flutter, and paced atrial rhythms. We also have sinus rhythms with first degree heart block, second degree heart block type 1, second degree heart block type 2, second degree heart block 2 to 1, and third degree heart block. These heart blocks are also called AV blocks, which is why you see the 2-degree AVB type 1, 2-degree AVB type 2, 2-degree AVB 2 to 1, and third degree AV block. Then we have our junctional rhythms. Junctional rhythm, accelerated junctional rhythm, junctional tachy, wandering pacemaker. And last but not least, we have our ventricular rhythms, normal sinus rhythm with an early ventricular beat, idioventricular rhythm, accelerated IVR, VTAC, VFib, and ventricular paced rhythm. So if you're interested in learning these rhythms. Please join me on my next video. My name is Carla from Teaching Trends. Until next time, everyone, take care.